All right, so this video is going to start or focus on 10.3. And the first thing we're going to realize is that if I look at 5 to the fourth as a power, that's going to be really 5 times 5 times 5 times 5. And when I multiply that out, I'll get 625. And a shorter way to write this, of course, is 5 to the fourth power. Now, notice also that these are in parentheses. This is really important because if I have negative 4 to the third power, that means negative 4 times negative 4 times negative 4, which is different than if I would have negative fourth to the third power, because that would just apply to the 4. So in this case, I would have negative, and I have 4 times 4 times 4. In either case, for this one, it will equal the same answer because I have an odd number of negatives, but it would matter if there was an even number. So make sure you pay attention to that. So basically, we want to figure out how you divide two powers that have the same base, is what we're going to be looking at today. So the key idea here is really if I have 4 to the fifth over 4 to the second, what does that really mean? If I go here, it's going to look kind of like this. It'll be 4 times 4 times 4 times 4 times 4 over 4 times 4. And when you divide these, 4 divided by 4 is just one whole. And I'll do that twice. And now I have, what I have left is 4 to the third. So that is the answer. And that's how you get this right here. And the algebra, how you write this out is a to the mth power over a to the nth power would really equal a to the m minus n. And a cannot be equal to 0 because you can't have 0 to a power. It just won't work here. So let's keep on looking at a few more here. Here's an example. So if I take this 2 to the sixth over 2 to the fourth, again, the bases are the same. So really, I would rewrite this as 2 to the sixth minus 4 equals 2 to the second power. And that equals 4. For this one here, I have 7 to the 9 minus 3. Notice it's in parentheses, so therefore it is negative 7 to the sixth power. And then this one here, I have h to the first power, because if I subtract 6 from 7, I have 1 left. So those are some examples. Here's a few more for you. So simplify this. So this would be 9 to the third. This would be 4.2 to the first. This would be negative 8 to the fourth in parentheses. And then x to the fifth. Again, make sure you put this in parentheses or it is not right. Another example here is if I have 3 to the fourth times 3 to the second over 3 to the third. I'm going to look at these here and I'll have now 3 to the sixth. I'll rewrite this. So 3 to the sixth over 3 to the third will equal 3 to the third, because 6 minus 3 is 3. This one here, I will go a to the 17th over a to the 10th. So then I have 17 minus 10, which is a to the 7th, right? Now notice how they set this up, which is totally fine to do as well. They have a to the 10 minus 6 times a to the 7 minus 4. And that would be a to the fourth times a to the third, or a to the third. And then they just add these together. So there's a few ways that you could solve these. So here's a couple of examples. Take a moment, pause the video, and see if you can solve this. All right, hopefully you got 2 to the 7th, d to the 5th, and 5 to the 8th. If we're looking at this land in Tennessee, where there's in 2030 is about 5 times 5.9 to the 8th power, predict the average number of people per square mile. Well, this is a square mile right here, is 5.96. So let's try this out real fast. So if I have 5.9 to the 8th, and it's 5 times this, right? Over, I have 5.9 to the 6th. Well, then I'll just have 5 times 5.9 to the second per every 1 square mile, right? Which, when I figure that out, will end up being about 174.05. And that would be people per square mile. So that's how you figure these out. And then, of course, we have our homework, but that is really the lesson for